All right, lesson 3, we're going to be talking about using rules of exponents. All of the stuff that we're talking about is foundational, so you're going to see this over and over and over again. So if you don't get it today, you're going to really struggle with it later on. So the better that you understand it today, the better chance you have of success tomorrow and the day after and the day after. So we all know, or we should know, what exponents are. That's basically it's repeated multiplication is what it is. Okay. The same way multiplication is repeated addition, exponents are repeated multiplication. So in an expression where we have, here we have such as x. Let's see, I think I've got something maybe missing there. Let's say x to the n. Okay, the exponent tells the number of times that the base is a factor. So if we have 2 cubed, or 2 to the third, is defined as 2 times 2 times 2. 2 times itself, where I have 3 2's, all being multiplied. Okay? But we are also going to see negative exponents. 2 to the negative third power is defined as 1 over 2 to the third. This is really, really important that you understand, and being able to go from here to this. Okay? Whenever I have a number to a negative exponent, I can rewrite it as 1 over that number to that positive exponent. Okay? Let's see. So let's try something out here real quick. Somebody give me a basic number.
3, 5.
Okay. All right. So 3, and I heard 5. Let's say it was 3 to the negative fifth. Let's go ahead and practice this concept. How would I rewrite that as a fraction with positive exponents? Go ahead. 1 over 3 to the fifth. That's exactly right. Okay? And vice versa. If I saw 1 over 3 to the fifth, I could rewrite that as 3 to the negative fifth. Okay? And essentially what has happened, if you keep this in mind, is that this 3 to the negative fifth is over 1. So I've created a reciprocal out of it, and whenever I move those things across the division bar, the exponent took the opposite sign. Okay? All right. So the formal definition of negative exponents is this, is that if I have x to the negative n, if n is any real number, and that's basically, you're not going to run into, in this class, working with exponents that are unreal. Okay? You don't have to worry about that. So whenever it says if n is any real number, that's not implying that, next week we're going to talk about exponents that are unreal. Okay? It's not in the immediate future anyway. So if n is any real number and x is any real number that is not 0, then x to the negative n is 1 over x to the n. We get that. So this definition says that when an exponential expression is written in reciprocal form, the sign of the exponent must be changed. Okay, that's the rule, is that I can move things above and below the division bar, but whenever I do that, the sign of the exponent has to change. Okay? So if it was positive, it becomes negative. If it was negative, it becomes positive as it moves across the division bar. Then you see that in the next sentence or so. If the exponent is negative, it is positive in reciprocal form. If it's positive, it's negative in reciprocal form. And we have reasons for moving a positive to become a negative and a negative to become a positive in order to evaluate expressions and simplify terms. Okay? So, again, this all looks like a lot. It's really not that complicated. And I know I'm talking really fast, but that's so that we can get to some of these questions and actually put hands on paper. 2 rules for exponents are the product rule and the power rule. If you understand these 2 rules and can keep them separate, you'll be miles ahead. Okay? These rules simplify operations with bases. The product of powers, okay, product means what? Let's use terms that we actually understand. What does product mean? Multiplication. So the multiplication of powers, or exponents, whose bases are the same, can be found in writing each power as repeated multiplication. Here we have our question, which is x squared times x cubed. X squared times x cubed. The product rule tells me that I take those exponents, okay, here we see it as, this is x squared right here, right? X times x, times, okay, we're going to multiply x times x by x times x times x. Well, what are the exponents to these x's right here as we see them as expanded multiplication? 1, 1, 1, 1, 1, 1. How many of them are there? There's 5. So we get x to the 5th, right? X times itself 5 times. Well, if I go back over here and look, is there another quicker way I could have gotten x to the 5th rather than expanding everything out? What could I have done with those exponents? Add them, right? Add them. Okay, so if I have bases that are the same and exponents that are different and I'm multiplying those terms, I just simply add their exponents. All right, the mistake that a lot of people make is, what do you think they do with that instead of adding? They multiply. They see the multiplication right there, and they multiply 2 times 3. Okay? We don't multiply in this case. We add, and if you have a hard time remembering that, think of this situation where we're doing x squared times x cubed. If we expand it, we can see it. Okay? All right. So the exponents may be added to obtain the same result. All right? So we've got x squared times x cubed equals x to the 2 plus 3 equals x to the 5th. That demonstrates the product rule of exponents. Product rule of exponents means that I add exponents, okay, whenever I multiply their bases. Okay? The product rule, okay, is a little different, or this is the product rule written out. Okay, this is not different. It's the same thing that we've covered. They're just using, instead of using numbers, they're using letters so that we could substitute in numbers for those letters. If I had x to the m times x to the n, my answer would be x to the m plus n. Okay, so it doesn't just work with numbers. It works with variables as well. Okay, does that make sense? Okay, because this is algebra 2, and by definition in algebra, we're going to work with undefined terms. We're going to work with variables. So we need to be able to understand the algebraic expressions and not just the numerical expressions. Okay? The power rule of exponents. This is what people are doing whenever they do the product power wrong. Okay? If we've got x to the m to the nth power, okay, that means that I'm going to multiply those terms. So somebody throw out some numbers for me. 2, I heard 2, 4, okay, and one more number. 6, okay, 2, 4, 6. All right, so let's say I had 2 to the 4th to the 6th power. Okay, what should my answer be in simplified terms? Nope, you're adding. That was the other thing. 2 to the 24th. Okay? Because this is, okay, let's see the expanded. Why does this work the way that it does? Because what we are saying is we're saying 2 times 2 times 2 times 2, right? 2 to the 4th to the 6th. So that's times 2 times 2 times 2 times 2. This would be 2 to the 4th squared, right? Right, I need to do that 6 times. So I got 1, 2, 3, 4, 5, 6, 7, 8, right? And keep going, right? I'm going to end up with 24 2s. Does that make visual sense? If I can see that here and it makes sense, I can understand the difference between the product rule and the power rule. I understand that the power rule is always going to give me a much bigger number. Well, not always, but usually. Okay? All right. Let's see. Scientific notation. Okay? How many of us in here are familiar? We know what the term, we're familiar with scientific notation. We know what it is. Great. All right, so it's a method for writing really, really big and really, really small numbers, and multiplying a number by a positive integral power of 10 moves the decimal point to the right. Okay, so we move things to the right, we move things to the left. Multiplying a number by a negative integral power of 10 moves the decimal point to the left. And we've got an example of some of this down here. You know, if our number is 412.36, and I want to put this as scientific notation, it has to be, well, let's see, in scientific notation, is a method for writing a number whose product of a number is greater than 1 but less than 10. So 412.36 is greater than 10. So we got to move the decimal point 2 places to the left, correct? Okay, so as we do that, we get 4.1236 times 10, and I moved it 2 to the left, so it becomes 10 squared. Okay, as I move it to the left, the number increases, okay, above my 10 by that far. Okay, if I have 0.041236 and I want to make that scientific notation, I'm going to move it 2 to the right. As I do that, okay, I'm subtracting. So I'm at -2. Okay. Right subtract, left add. Writing very large or small numbers in scientific notation can be helpful. And we can take scientific notation and multiply it by other scientific notation. Okay, in which our rules will still apply on how we simplify that. So rules of exponents can be used to simplify expressions written in scientific notation. All right, so that brings us to the end of this. What you guys should have is you guys should have a sheet here right next to your notes in your classroom. Algebra 2, lesson 3, right? All right, you guys can see this. I know that you can't see it in the video because I haven't pulled it up, but you guys should be able to pull this up in your Chromebook. I want you to have this up because we're going to work out some of these questions on the board. You guys are out of here at what, 10:36? Okay, 10:36. So I'm going to try to work until 10:26. Make sure that you guys have some time to work on your homework, okay? So I've got about we've got about 8 minutes. All right, so let's look at just the very, very first one, okay? No substitution. It is just algebraic. So it gives me something like m to the 2 plus a times m to the a n to the 3a over m squared into the 2a. Okay, so order of operations. What happens first? Allison, what happens first in order of operations? Parentheses. Can I reduce m to the a times n? No, they won't reduce. Okay, so what comes next? Exponents. All right, do I have exponents that need to be simplified? Yeah, m to the a times n to the 3a, right? Okay, so what is the exponent to n in this grouping symbol here? 1. Okay, so I'm going to put it in there just so I know that it's there so I don't end up skipping it. So we're not working with m to the 2 plus a right now. All right, so let's look at this. M to the a to the 3a. What does that become? M to the, I heard somebody say 4a. Is that right? No. Because what am I doing between a and 3a? Multiplying. What is a times 3a? 3a squared. Okay, so you've got kind of double exponents there. And then n, okay, n becomes what? Into the 3a, because 1 times 3a is 3a. So I have all multiplication across here, right? Okay. Do I have any same bases? Yes. What bases do I have in common? Axel. M. Okay, so I'm taking m times m. Whenever I take m times m, what do I do with those exponents? I multiply them or add them? Add them. So I need 2 plus a plus 3a squared. What does that become? Think about like terms. Okay, if I have to, let's split it up over here. What's 2 plus a plus 3a squared? Are any of those like terms? No. But what does that look like? Does that look like a quadratic equation? Yeah, so I can just simply write that all together as 3a squared plus a plus 2, right? Okay, now n doesn't have any friends up here, so he's just n to the 3a, right? All right, let's pull this down here a little bit. Okay, so I've simplified my numerator as far as I can with this answer right here. Okay, let's go ahead and grab our denominator. M squared and then into the 2a. Okay. Now, because this is multiplication here and this is multiplication here, I can move things up and down from the division bar, right? Okay? And I want to simplify this as much as I can. Do I want to pull the numerator m down, or do I want to lift the denominator m up? Denominator m up, I hear, okay? And what about the n to the 2a? Do I want to bring the lower one up or the upper one down? Lower one up, okay? So let's see what that looks like whenever we do that. Let's go ahead and pick a different color so we can see the difference here. We got m to the 3a squared plus a plus 2 times m to the what? Whenever I bring this up, what does it become? Negative 2, okay? Now, before I move on, let's just go ahead and talk about that, okay? What do I do with this? What am I doing with the exponents to them? Add them, all right? So that's 3a squared plus a plus 2 minus 2. What happens? The 2's cancel. Very good. 2's cancel. So I'm left with m to the 3a squared plus a, right? All right, let's come back up here. Let's look at, we have n to the 3a times n to the what? Negative 2a, right? Change sign. Okay, so what am I doing with those exponents? Adding them. All right, so what's 3a plus negative 2a? 1a, or just a? Sorry. N to the a. If you are sitting here and you haven't written anything down, right, you are hurting yourself, right? Because I think I've told you guys this, is that questions from these documents are what I make your test out of. Not like I don't just make up questions. I pull questions from these sheets. And this is how I make these, is that I have a test generator, and it has a limited number of questions for each lesson. And so whenever I make these sheets, you know what I do? I pick every single question that the test generator has for this lesson. So by the time that we get to test time, you have seen not only every question that's on the test, but I believe if you go and scroll all the way down to the bottom of that document, do you guys have an answer key? So not only, if you look at these and you study them and you actually kind of work on them a little bit, you will have seen every question that's going to show up on your test and what? And every answer to every question for your tests. So are these worth spending your time looking at, familiarizing yourself a little bit? And if I'm going to work a question out on the board, what should you be doing, pencil, paper? Probably writing down the work, okay? What I want to see is, you know, up and down, okay? Not just staring at me, okay? Because if you're just listening to me, you're only catching a small fraction of what there is to get, okay? All right. At that, I'll probably stop right there. I'm going to let you guys work on your homework. I'll walk around the room, okay, see if I can answer any more questions for you.